Hey math students, I hope you all are doing well. Today's lesson is the introduction to right triangles and the Pythagorean theorem. We're going to start off with a warm-up. So I just want you to go back into the depths of your brain and remember how to draw the following angles: a right angle, acute angle, and an obtuse angle. So go ahead and pause the video and try those out. Alrighty, so the key for each of these is kind of remembering what these mean. So a right angle is a 90-degree angle. That's 90 degrees. And an acute angle is less than 90 degrees. And an obtuse angle is more than 90 degrees. Or greater than 90 degrees. So right angle looks like that. The key to know whether it's a 90-degree angle, it will have this little square in the corner to verify this is a 90-degree angle. And then acute will be less than that. So we could draw an angle like that. It's less than 90 degrees. And then more than 90 degrees just has to be greater than that square. So there's an example of greater than 90 degrees, obtuse. And so we're going to be using the definitions of these angles to talk about triangles. So we have some triangle definitions that have those same words: acute, right, and obtuse. So an acute triangle means each angle in the triangle is less than 90 degrees. So all the angles are acute. What? Acute triangle. Yeah. And then the right triangle just means one angle is 90 degrees. And so you can see it has that square to show that it's a 90-degree angle. And then obtuse means one of the angles is greater than 90 degrees. So it has one obtuse angle. And then the notes at the bottom, it notes that the names of angles are often a capital letter, and the side across from the angle has the same name but lowercase. So this is often the naming convention. So for instance, I see here's angle A, it's a capital letter, and then the side across from it is side A with a lowercase letter. We can look at angle B. It has a capital letter, an uppercase letter, and then the side across from it is lowercase b. And then you can see the same is true for angle D and side D. And then there's this final note down there. We will also be using the variable theta. So in case you haven't seen this before, that is pronounced theta. That's a Greek letter, like pi. So that's a Greek letter that is a variable to represent an angle, and we're going to be using that to represent missing or unknown angles. So right triangles are what we're mainly going to be focusing in on class, and there's some specific vocabulary for right triangles. Okay, so you can see I have a right triangle because there's that little square. And then we have this angle theta. So there's my theta that we're looking from. The angle across from the right angle is the hypotenuse. So the hypotenuse is always the longest side. You can see that right here. The hypotenuse is always the longest side, and it's across from the right angle. Next, the opposite. And more specifically, we call this the opposite leg, because this is a leg, and this is also a leg. Anything that's not, oopsies, the hypotenuse is not a leg. I made a mistake. All the sides other than the hypotenuse are called legs. So we have the hypotenuse, and then we have our opposite leg and our adjacent leg. Those are legs. And then I have the hypotenuse. So the opposite leg is what it sounds like. We have our angle, and then the side opposite is the opposite leg. So it's across from it. It's opposite. And then adjacent means next to. So adjacent means next to. It means next to. And so then the side that's next to the angle is adjacent. It's the adjacent leg. So this is some vocabulary you need to become familiar with. For our example on the next slide. Here it is. Alright, so given the right triangle below, or over there, answer the following questions. So I can see that I have sides A, B, and C, and I need to figure out what's the hypotenuse. So hypotenuse is always across from my right angle, and the side across from the right angle in this case is C. Which means my other two sides, those are my legs, A and B. So A and B are legs, while C is the hypotenuse. Alright, now we're going to look at angle theta. So there's my theta, that angle. And we're asked which side is opposite of angle theta. So opposite means across from. A is opposite of angle theta. Okay? And then, oopsies, what side is adjacent? What side is adjacent to angle theta? Adjacent means which side or which leg is next to angle theta. So side B is next to it. Okay? I think it's really important for me to know that the opposite leg and the adjacent leg change depending on which angle you're looking at. So in this example, we were looking at angle theta, but I see that there's another angle. I could call this angle beta. Okay. And if I asked you which angle is opposite of angle beta, now it's all turned the other way. Now I would say, oh, side B is opposite of angle beta, and side A is adjacent to angle beta. So the opposite and adjacent really depend on the angle that we're talking about. So you need to always make sure to determine, okay, what is the angle that I'm looking from? Righty. Okay, so Pythagorean theorem now. You've probably heard of this thing. So all that it says is, given two sides of a right triangle, so I have to use a right triangle to know that this equation will work. If I don't have a right triangle, this equation will not work. So if I'm given two sides of a right triangle, we can calculate the third side using this equation. A squared plus B squared equals C squared. And I love the color coordinating on this picture because it's really important to note that the legs are A and B in this case, and those are what you add together. So we square the legs and we add them together, and then they end up being equal to the hypotenuse squared. Okay? And remember, the hypotenuse is always the longest side. So this equation only works if we have our hypotenuse, the longest side, on the side by itself. Okay? So the two smaller legs squared add up to equal the one longer leg, which is the hypotenuse, or the one longer side, which is the hypotenuse. So it is really important that the hypotenuse is always the side that's on its own. Let's do some examples. So example 2, calculate the missing side of each triangle. Woohoo! So in this one right here, I can see that I'm missing the hypotenuse. So it's really important to determine what we're missing. Is it a leg or is it a hypotenuse? In this case, I know I'm missing the hypotenuse because it's across from the right angle. And so when I set up my A squared plus B squared equals C squared, it's important that I know that this is C, the hypotenuse. And then I can fill in the other legs. So 6 squared plus 8 squared equals c squared. And honestly, it doesn't really matter which one I make a and b. The legs are kind of interchangeable. So since we're just adding them up, a squared plus b squared, I could call either one a and either one b. In this case, I called a 6 and b 8. Okay. So now it's just mental math from here. 36 plus 64 equals c squared. 36 plus 64 is 100. And then I need to solve for c. So I know what c squared is. C squared equals 100. In order to solve for c, I will take the square root of both sides. Square root of 100 is 10, and so that is the value of c. Which makes sense. But remember, the hypotenuse is the longer side, so it has to be the biggest number. Okay. All right. Now we're missing. I see that I have the hypotenuse. So here's my c, and I can call this a. That means I'm missing b. I'm missing one of my legs. Anyway, I'm missing one of the legs of the triangle, and I need to find it. So a squared plus b squared equals c squared. A squared is 2. I don't know what b is. And then c squared, c is 7. So I have 4 plus b squared equals 49. And now I need to solve for b. So I'll subtract 4 from both sides. Get b squared equals 45. And then I take the square root. And I get b equals the square root of 45. And you could leave it like that. I'd honestly rather you leave it like that than put it in a calculator and get a decimal. But what I would most prefer if we were able to simplify this, and so I'll show you a cool trick to simplify this, a really cool trick, is I know 45 is 9 times 5. So I can't take the square root of 45, but when I split it up into 9 times 5, I see that I can take the square root of 9, right? The square root of 9 is 3. And I don't know, I can't take the square root of 5 nicely, and so I leave it like that. So either of these answers are good. I would say this is the best one because it is the most simplified. Okay? All right. And then the last example is a little word problem. So we're told Simon is hiking. Simon, they walk 4 kilometers due east. Okay, I need to draw a picture. Sometimes when you start a word problem and then you get confused, it's good to draw a picture. So here's Simon. They walk due east. So east is this way, right? Never eat soggy waffles. That's how I remember it. Northeast, southwest. So east is that way, and he goes east 3 kilometers. And then, oh, sorry, he goes east 4 kilometers. And then 3 kilometers due south. Like that. And so Simon ends up here. How far are they from their starting point? So we know that Simon walked a total of 7 kilometers. They walked 7 kilometers total. But what we're trying to figure out is this. How far is Simon from their starting point? So we've got to find that length, which in this case is the hypotenuse. Because since they walked straight east and then straight south, that forms a right triangle. Ooh, how convenient. So we can use our Pythagorean theorem, which I think you at this point can set this problem up and solve on your own. So you do it on your own as I work as well. Okay, did you get 5? We want to make sure, since it's a word problem, we use our units. So I'm going to write it as 5 kilometers. The final answer is 5 kilometers. Simon is 5 kilometers away from their starting point. Cool. So on the next slide, we're going to do these are like kind of more basic problems. Example 3 is slightly more challenging problems. So first we start off with another word problem where we're probably going to have to draw a picture. So I really recommend with any problem dealing with geometry and shapes, drawing a picture is your friend. So it says a ladder is resting against a wall. Its base is 2.5 meters from the wall and it reaches a height of 8 meters. Calculate the length of the ladder. Ooh. So I want you to try to visualize what this problem looks like. So what is the situation with the ladder? I want you to try to visualize it and do a sketch. And then I'll show you what I am visualizing as well. So you try it first. This is what it looks like to me. It's a ladder leaning against a wall. And then we got to fill in some numbers. So the base of the ladder is 2.5 meters from the wall. So that's this distance here, 2.5. The base of the ladder is the bottom of the ladder. So the bottom of the ladder is 2.5 meters from the wall. That's what that looks like. And then it reaches a height of 8 meters. So the top of the ladder right here reaches a height of 8 meters. So that is that length here. And of course, I know you see what I see. It forms a right triangle, doesn't it? Yes, it does. So the wall and the floor always form a right triangle with each other. Amazing. And so we need to figure out, what is this here? What is this side? Which is the hypotenuse. So let's do it one more time. Okay, this is what I got. And if you're really dying, like if you look at this and you're like, I don't know what the square root of 68.25 means, since there's already a decimal in there, you can put it in a calculator and get an approximation. So I'll do that just to show you what this might look like. So 68.25 square root. But I would have to say that C is approximately 8.261. And so when you give an approximation, or when I convert it to a decimal, this is an approximation because the decimal that it gave me was a lot longer than this. I'm going to round to the nearest 3 decimal places, and I'll make sure to say that this is approximately what it is since I'm rounding. Okay. And then I'll add my units, which is meters, right? Metric system. Yeah, we know what the metric system is. Okay. And then finally, we have these last problems, which are kind of wild. They're just a little bit more challenging because these shapes don't look like triangles to me. And we're supposed to find the missing, we're supposed to solve for x. And I'm looking at it and I'm like, this isn't a right triangle. How am I supposed to do this? I'm not equipped for this. But don't worry, you are. So just like we were able to find right triangles in our drawing, like here of the ladder, and we were able to find a right triangle here in our drawing, we're going to do the same thing in this word problem. So I am going to draw in a right triangle that uses this side right here. So it's going to include that side right there. And it's just, we got to be creative. This is where your artistic side can come through. Do you see what I just did there? That's totally a right triangle. Okay, so I drew it in there. And you might be like, well, that's not helpful. I don't know either of the sides. I need to know at least two of the sides in order to solve for x. We can figure it out, don't worry. So you see here, 3 meters down at the bottom. This length on the bottom is the same as this length right there. Those are equivalent. So I know this is 3 meters. Okay. And then I need to know what is just this little piece right there. What is that side? So I know the whole side is 5.5. But then we're subtracting this little piece right here, which is 3, because it's the same as what's across. It's the same as that. So the whole thing is 5.5, but we don't want to include the 3 down there. So this side is 2.5. So basically, I could redraw this to make it easier to see. This side is 2.5, this side is 3, and then that's the x that I'm looking for. That's what I need to find. Okay? So we just have to be a little creative. Again, you know, you're just solving for the hypotenuse. You know how to do this. So it's going to be 3 squared plus 2.5 squared equals x squared. That's 9 plus 4.25 equals x squared. 13.25 equals x squared. So x is the square root of 13.25. Easy. Okay. Then we have this thing, which kind of looks like a triangle, but it's not. It's like a paper airplane shape. And I need to find, basically, I want to kind of hone in on this triangle here. So this is the triangle. It's like we're thinking about this as 2 different triangles. Okay. So in order to figure out the hypotenuse x of this triangle, I need to know the 2 other sides. So I need to know what is this. I'll call it y. I need to know what is y. And I can figure out why. Look at what's below. There's another right triangle below here. So for this yellow triangle, I need to find y, which is the hypotenuse. So I can solve for y here. It's 2 squared plus 4 squared equals y squared, since y is the hypotenuse. So 2 squared plus 4 squared is 20. And then I take the square root, so y equals the square root of 20. Got it. And now I can solve for x. So now I have 2 sides of the red triangle and I can figure out x. So that's going to be 3 squared plus the square root of 20 squared equals x squared. Okay, get your practice in. Work ahead of me as I also solve this problem. That's it.